or Euler's predictor corrector method or Hewin's method or Runge-Kutta second order method. So many names. So here also you can write Runge-Kutta first order method in Euler's forward method. Now I am explaining the formula. Initially y1 is computed by Euler's method, Euler's formula, that is y1p is equal to y0 plus h f of x0 comma I0 and the modified value of y1 is given by y1c is equal to y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma y1p. Here p indicates predictor, C indicates corrector. Correcting that. First of all, predicting that y1 by Euler's method, and to get the accuracy or to modify, improved, that is so many names, we are using this y1, this formula as y1, modified value of y1. This C indicates corrector. So 3 methods, please by heart all the recurrence, iterative formulas, or you can say recurrence also. Similarly, we can compute, we can find y2, y3, so on. So here what I have done here put, you can write I is equal to 0 in Euler's formula. This is obtained by Euler's formula after taking I is equal to 0, and we improved or modified another value of y1. Next RK method I am giving. Runge-Kutta method, which which is also known as RK, that is Range-Kutta method of, or better to write Range-Kutta fourth order method. First order RK means Euler's forward iteration formula. Second order means second order RK means modified Euler's. Fourth order, and syllabus is not containing, that is third order RK method, which is also known as Range's method, but it is not in the syllabus. Only these three: RK first order, RK second order, RK fourth order. The RK fourth order iterative formula is yi plus 1 is equal to yi plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4, where k1 is equal to h times f of xi comma yi, k2 is equal to h times f of xi plus h by 2 comma yi plus k1 divided by 2. K3 is equal to h times f of xi plus h by 2 comma yi plus k2 divided by 2. And finally k4 is equal to h times f of xi plus h comma yi plus k3 for I is equal to 0, 1, 2, so on. So all of you, those who are finished, please by heart all the iterative formulas. So in all these formulas, in all the above, H is step size and xi is equal to xi minus 1 plus h for I is equal to 1, 2, so on. That is, x1 is obtained by adding h to the initial x value, that is x0. x2 is nothing but x1 plus h, comma x3 is equal to x2 plus h, etc. Similarly, y1 is nothing but y of x1, because y0 I have given. y2 is nothing but the value of y at x2, and so on. So this is the relation between two consecutive x values. This is the relation between two consecutive y values or two consecutive x values along with h. So in every formula I have given yi plus 1, where I is equal 0, 1, 2. Y0 is the starting value. Next, first step we need to find y1. Next step we need to find y2. So where you stop this procedure, that depends on the nature of this problem. That is, for some x, you find y value after taking the step size h. Then we know how to, where do you stop these formulas. Okay, starting x value x0 is available, and y0 starting value of y is available. But the question requires find the value of y at x is equal to some number. Depending on that only and the step size h only, we came to know that where do you stop the procedure. That is, up to calculating y1 or up to calculating that y2, y3, y4, that depending on the situation of the problem only. Now I am giving the examples. First problem. Which is given 2 marks, GATE 2010. Consider a differential equation d by dx of y of x minus y of x is equal to x with initial condition y of 0 is equal to 0 using Euler's method, comma, with a step size of 0.1, comma, the value of y of 0.3 is dash. Here remove comma. So first order equation is given. You express in the standard form. What is standard form for all these methods? Left side only containing dy by dx, no numbers, no variables, no other terms. If any other terms, you send into right side. Then only you will be getting f of xy. GE stands for given equation is dy by dx. Y of x can be simply denoted by y. Y is a function of x because here y is dependent, x is independent variable. This is dy by dx is equal to x plus y. So what is this x plus y? According to our standard form, f of x comma y, comma, with what is the condition given? Y of 0 is equal to 0. The meaning of this initial starting values of x and y, x naught 0, comma, y naught value 0. Y is a function of x, so the inside value is nothing but independent variable value. That is, here x is independent, y is dependent. Okay, and the right side is nothing but the y value only. And h is also given 0.1. Which method is going to apply? Which method is mentioned? Euler's method. The Euler's iterative formula is yi plus 1 is equal to yi plus h times f of xi comma yi. Okay. So go on giving one by one value starting with 0. Where do you stop the procedure? Until to get y of 0.3 with the step size of h is equal to 0.1. So I is equal to 0 implies y1 is equal to y0 plus h times f of x0 comma y0. So what is y0? 0, h value 0.1, f of x0 0, y0 0. What is the meaning of f of 0 comma 0? In the function of x comma y, put x is equal to 0, y is equal to 0. So 0 plus 0. So this simplifies to into 0 is equal to 0. So what is y1? Y of x1. So what is y of x1? X1 value is just now I gave before this problem x0 plus h. So h value 0.1, x0 value 0. So x1 is equal to 0.1. That means the first step gives the value of y at x is equal to 0.1 until to reach 0.3. This problem is over. Okay. Since x1 is equal to x0 plus h is equal to 0.1. Step 1 is over. Now, for I is equal to 1, comma, y2 is equal to y1 plus h times f of x comma y1. The y1 just now we evaluated, we got 0, h is 0.1, f of x1 I have given there 0.1, y1 0. What is the meaning of f of 0.1 comma 0? In f of x comma y, that is x plus y, add these values. So this simplifies to 0.1 into 0.1, that is 0.01. So what is y2? Y of x2. What is y of x2? x2 value is x1 plus h. x1 value 0.1, add h, which gives 0.2. So this 0.01 is the value of y at x is equal to 0.2. This 0 is the value of y at x is equal to 0.1. But where we have to find? At 0.3. That means we need one more iteration. And I is equal to 2, comma, y3 is equal to y2 plus h times f of x2 comma y2. What is y2? We got 0.01. What is h? 0.1. f of x2 value 0.2, y2 value 0.01. What is f of 0.2 comma 0.01? According to given f of x comma y, add the values. 0.2 plus 0.01 is 0.21. So this is 0.01 plus 0.1 times 0.21. Now 0.21 into 0.1 is 0.021. So this simplifies to 0.031. What is y3? Y of x3. What is x3? x2 plus h, that is 0.3. So this is the 0.031 is the value of y at x is equal to 0.3. This is the procedure. Make it fast. Easy to understand. One by one step I have done in such a way that with the reasons also. Not a tough problems. Another example, which is given 2 marks, GATE 2006. The differential equation, I am writing short notation dg, dy by dx is equal to 0.25 y square is to be solved using the backward in bracket other word is given, that is I already told you, other name is implicit. Euler's method with y is equal to 1 at x equal to 0, that is initial condition, and step size of 1, full stop. What would be the value of y at x is equal to 1 question mark? So this problem by backward Euler's method. First problem is forward Euler's method. Solution. GE stands for given equation is dy by dx is equal to 0.25 y square. So this is already standard form. So whose right side is denoted by f of x comma y with the starting values of x and y, that is x naught 0 comma y naught value is 1 and step size h is value 1. This is the given problem, given data. The backwards Euler's iterative formula is yi plus 1 is equal to yi plus h times f of xi plus 1 comma yi plus 1. Now just first of all simplify this value. Here I have given f of x comma y. Replace xy by respectively xi plus 1, yi plus 1. So this simplifies to yi, what is h given? Value 1 times f of here f of x comma y is 0.25 times y square, that is absent of x term. So here replace y by yi plus 1 in the given function because it is absent of x, which simplifies to 0.25 yi plus 1 square. Now bring all the terms to one side. It is a square equation in yi plus 1, which is giving a quadratic equation. So yi plus 1 square along with 0.25 minus yi plus 1 plus yi is equal to 0. Now I am taking first I is equal to 0, comma, we have 0.25 y1 square minus y1 plus y0 is equal to 0. So what is y0 is given? 1. So this is a quadratic equation in y1. Therefore you know how to find y1. Minus b plus or minus square root of b square minus 4ac whole divided by 2a. That is quadratic equation roots. So minus b means plus 1, plus or minus b square means plus 1, minus 4 into a value 0.25 into c value 1. So minus 4 times 0.25 divided by 2a, that is 2 into 0.25. So this simplifies to 1 plus or minus 4 into 0.25 value 1. 1 minus 1 0, square root 0 0. So 2 into 0.25 is 1 by 2. Okay. So therefore y1 is equal to 2. What is y1 meaning? Therefore y of x1. What is x1? x0 plus h. h is 1, x0 is 0. So y of 1 is equal to 2. This is your x1. x1 is equal to x0 plus h. Because of x1 is equal to x0 plus h. So that value gives the value of y at x is equal to 1. Answer is 2. Just here in the right side f of x comma y, only y term is present, x is absent. That is why here I replaced y by yi plus 1 along with other. Other means 0.25. Now another example, 2013, 2 marks, this is given. While numerically solving the differential equation, DE stands for differential equation, dy by dx plus 2xy square is equal to 0, comma, y of 0 is equal to 1, using Euler's predictor corrector, in brackets other name is improved Euler-Cauchy method with a step size of 0.2, comma, the value of y after the first step is easy to understand, no difficulty in these problems. Solution. I am going to write directly the given equation with standard form, that is sending 2xy square to the right side becomes minus 2xy square. So this including symbol number xy square, which is our f of x comma y, with initial values x0 0, y0 1, because of y of 0 is 1, and step size is also given how much? 0.2. These two conditions, starting values of x and y, can be given in the form of y of 0 is equal to 1. the Euler's predictor corrector formula is, first you find initially y1p, what I have discussed earlier before these problems, got by Euler's first order method, forward Euler's method, y0 plus h times f of x0 comma y0. What is y0? So y0 is 1, h is 0.2, f of x0 0, y0 value 1. So how to find f of 0 comma 1? In your f of x comma y, substitute x0 y0. So 2 into 0 gives 0. So 1 plus 0.2 into 0, this simplifies to y 1. And modified value of y1, that is y1c, is equal to y0 plus h by 2 times f of x0 comma y0 plus f of x1 comma y1 predictor. What is y0? 1. What is h? 0.2 by 2 simplifies 0.1 times f of x0 0, y0 value 1. F of x1 formula is x0 plus h, so this becomes 0.2, y1p we got 1. Since x1 is equal to x0 plus h is equal to 0.1. Now this is equal to 1 plus 0.1. First f of 0 comma 1, that means in f of xy put x0 y1, which simplifies to 0, plus f of 0.2 comma 1, in this put x is equal to 0.2, y is equal to 1. So minus 2 times 0.1 times y square, 1 square. So this simplifies to minus 0.2 into 0.1. This is 0.2. Minus 2 into 0.2 minus 0.4 into 0.1 is 1 minus 0.04. This simplifies to 0.96. So that is the value of y at x is equal to 1. So therefore the value of y, what is the question required? After first step, that is y1c comma is 0.96. That is the conclusion. So like this I am giving you a problem to you. So solve by Range-Kutta method. In one step I will mention. You only solve. I will give the answer along with hint also. Fourth problem. Given dy by dx is equal to x plus y, that is already in standard form. Initial condition is y of 0 is equal to 1, that is y value 1, x value 0, full stop. Find y of 0.1 by taking h is equal to 0.1 and using Range-Kutta method. This is already standard form. Your f of x comma y is x plus y. Y naught value 1, x naught value 0. H value given 0.1. So in one step only you will be getting this answer. But which method? RK method, means Range Kutta method. That is fourth order only. That fourth order Range Kutta method commonly known as RK method. Just I am giving hint. F of x comma y is equal to x plus y, comma h value 0.1, comma x naught 0, comma y naught value 1. Using RK method, comma y1 is equal to y naught plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Say equation 1. Just I have taken I is equal to 0 in your RK method formula, where k1 is equal to h times f of x naught comma y naught. k2 is equal, just put I is equal to 0 in your RK fourth order method. Sorry, this is 0. k3 is equal to h times k4 is equal to h times f of x naught plus h, comma y naught plus k. Don't worry this formula, just I have taken directly I is equal to 0 because we need only y1. Here y1 is nothing but y of x1. Your y of x1 is x naught plus h value already 0.1. Since x1 is equal to x naught plus h, that is 0.1. Later you check, this is 0.1, 0.11, 0.1105, 0.12105. Therefore 1 implies y1 is equal to, just substitute these things, simplify. Answer is y1 is equal to 1.11304. Sorry, 11034. Later you check this is correct or not. And one more problem I am giving you. Fifth problem, which is given 2013, using Euler's method, comma, to solve, don't put comma, the differential equation, D stands for differential equation, dy by dx is equal to 2 times cos 4 pi x by 3 minus y, comma, y of 0 is equal to 1 with step size h is equal to 0.25. Answer I am giving. Later you check. We have done already Euler's method one problem. 1.1875. This is the answer. So it is already standard form. This term is nothing but your f of x comma y. X naught value 0, y naught value 1, h value 0.25. Look at your first problem in Euler's method.